Alright, we are doing exercise 29 in section 1.3 of Stewart's Calculus 7th edition, Early Transcendentals. And the question here asks find f plus g, f minus g, fg, and f over g and state their domains. And for 29, we have f of x is equal to x cubed plus 2x squared, and g of x is equal to 3x squared minus 1. Okay. So a, in this case, we're just going to add both functions together. So we're going to write out f. Let me do it in a different color. Let's do f is equal to x cubed plus 2x squared. Okay. And then we're going to add g. I'll do that in a separate color. And g is just 3x squared minus 1. Okay. That's the full function. That is equal to f plus g. Now we can simplify this by adding the x squared terms together, and we're gonna get this x cubed plus 5x squared. 2 plus 3 is 5 minus 1, and that would be f plus g for this particular problem. Right. B is f minus g, and sometimes the minus part trips people up, so I'll show you how to properly do this. F we write first, and then you do minus the quantity g. So 3x squared minus 1, distribute the negative to each term in the quantity, and you have now x cubed plus 2x squared minus 3x squared plus 1. Negative 1 times negative 1 is plus 1. And then we simplify by adding together 2x squared and negative 3x squared, and you're going to get the result, which is x cubed minus x squared plus 1. Okay, 3 plus negative 3 plus 2 is negative 1. And then your x squared is just the term. Fg, that would be f times g. So here we have f times g, that's just, we'll do it in quantities, so x cubed plus 2x squared, that's f, times g, quantity g is 3x squared minus 1, okay, and we're going to FOIL, so I just say, distribute each term. Okay, so x, this is now, what color did I do? I need green still? No, I'll do cyan. So x cubed times 3x squared would be 3. You multiply together their coefficients, so 3 times 1 is 3. And then you add the exponents, okay? Sometimes people forget that. So 3x, and then 3 plus 2 is 5. So 3x to the 5th. And now we'll do x cubed and negative 1. That would be negative x cubed. That was easy. And now we'll do this term, and we'll do that, like that. So now we have 2x squared times 3x squared. Multiply the coefficients, so 6, and then add the exponents to the 4th. And then 2x squared times negative 1 is just negative 2x squared. And we can rewrite this in a more proper fashion. So 3x to the 5th, and then plus 6x to the 4th, minus x cubed minus 2x squared. And I just wrote it in order of exponents, the powers, 5, 4, 3, 2. And unfortunately we don't have 1. Also sad. Okay, D. This is f over g, so we're going to write f first. I believe it was x cubed plus 2x squared. Am I right? Yes. Over the quantity g, which is 3x squared minus 1. And let's see. You can't factor anything out, so can you? Can you? You take out x squared, it would be x. No. I think this is in the most simple form. This is the simplest you're going to get with this, I believe. So This is exercise 29. Not too difficult. Oh, and we're supposed to state the domains. Okay, so I'll do that really quick. This is a polynomial, okay, and all polynomials, their domain is all real numbers from negative infinity to positive infinity. So here, actually, here, and here, they're all polynomials whose domain is from negative infinity to positive infinity. And then this one's domain is all the points where this is equal to 0. So we'll set 3x squared minus 1 equal to 0. You get 3x squared is equal to 1. Add 1 to both sides. Divide everything by 3. You get x squared is equal to 1/3. And then, 1/2. 1/3. And then find the square root to cancel that x squared. And you get that the domain is your function is undefined at when x is equal to square root 1/3, but that is both positive and negative square root. So the domain for this is going to be negative infinity to negative root 1/3 union. Oops. And then, oh boy, it's going to be negative 1/3 to positive, and then union again from positive root 1/3 to infinity, and that is the domain of that. Okay.